Hey guys, it's us again! Welcome to Petals for your troubles.
And today we'll be helping you solve electric field. Problem. Two charges are placed on the x-axis. One charge, Q1, equals positive 8.5 times 10 to the negative 6, is at 3.0 cm, and the other, Q2, negative 21 times 10 to the negative 6, is at 9.0 cm. Find the net electric field, magnitude and direction, at 0 cm and 6.0 cm. So we're going to put the problem in the lower left side so you guys will be guided through this video. Now let's start with the given. I'm going to put the first charge, which is positive 8.5, and then its placement in centimeters, 3.0 cm, and then Q2, negative 21, and then its placement in the x-axis, which is positive 9.0 cm. Now, to help us just be sure not to be confused, we'll just expand this in the scientific notation form. And then for our formula, we have to convert the cm into m, which gives us 0.03 m. Then our second charge times 10 to the negative 6, and then 0.09 m. And that's our given. So that's step 1. Now on to our asked, which is find the net electric field. Magnitude and direction at 2 points. 0 cm and 6 cm, or 0 m and 0.06 m. Since we're looking for net electric field, and net just means a summation of all, to make our solutions a little less complicated and a little less long, we're just gonna put it in a form where instead of adding everything one by one, we'll just add everything for point A, which is 0 m, and point B, which is 0.06 m. So with the use of brackets and parentheses, we'll just make our equations smaller and compounded. So that explains our solution format. We're going to be using the formula E equals K, absolute value charge, over R squared. And this is to solve for electric field. Now K is a constant, which is 9 times 10 to the power of 9. So we'll start with the first one. If we just input the constants with the charges, first in terms of A, which is at 0 cm. Now we'll just follow the formula and plug everything in, the charge and the R. Now, based on the laws of distance and positive negative charges, that will determine what our R will be. Now you have to consider the placement of the Q1 and Q2 and the point. So if you just input that in your calculator, that will give us an answer of that, but in scientific notation form, it'll be 6.2 times 10 to the power of 7. Now, if you get a negative answer, it's okay. That just tells us it's either away or towards. It's just the direction. Now off to the second point at 6, or 0.06 m. Now we have the constant K, and then the first charge, (8.5 times 10 to the negative 6 over 0.03 squared). Plus the second charge, negative 21 times 10 to the power of negative 6 over 0.03 squared. Again, the reason why our r's would change is based off of the rules in negative and positive charges and the distance between the two. You'll have to get into the concepts of that more, because in certain times you'll have to subtract or change the sign based on the distancing, and if you just input that in your calculator, that'll give you an answer of 2.95, or basically just 3.0 times 10 to the power of 8. And now it's time for our answers. At 0.0 cm, the net electric field will be 6.2 times 10 to the power of 7 away, or leftwards. And B, at 0.06 m, it'll be 3.0 times 10 to the power of 8 towards, or rightwards. So the unit of electric field is N over C, which is newtons per coulombs.
And that's it! Don't forget to like and subscribe!
Okay, bye!
Bye!